Welcome back. In this video, we're gonna try to solve this value, okay? By assumption, this is finite. That's why we write x is the cubed root of 6 these nested radicals, okay? That means this is going forever, okay? And one way of solving this one, they look tricky, but we can find them very quickly if we pay attention. So here, if we call this whole number x, we can start from here. And we looked at this is the same because this is infinite. So this number is the same. Therefore, we can write it as x is the cubed root of 6 plus x, because here this is the same as our x, okay? And therefore we can cube everything. We can have x cubed is 6 plus x, and therefore we have an equation of a third degree. It's a binomial of a third degree that we have to find. We have a formula. It's long, but sometimes a trial and error can help us find the solution. Here we can try by using small numbers. I can see that 2 is a solution. Why? Because 2 cubed is 8 and 6 plus 2 is a solution. Therefore, this equation, which I can write as x cubed minus x minus 6 equal 0, can be written as x minus 2, because 2 is a solution, and I can factor out by x minus 2 times a binomial of a second degree. Okay, here I can find this binomial by expanding and equating the coefficients with these coefficients of this binomial that I have. So this is what I'm gonna do here. A quick way is that we can see that we can get x cubed only by multiplying x and x squared, and therefore we can find that a is 1. But let's just do the work and see that this is ax cubed plus bx squared plus cx minus 2ax squared minus 2bx minus 2c is 0. Now I collect terms of similar powers. So I have ax cubed, and the square I have b minus 2a x squared plus c minus 2bx minus 2c is 0. Here, this is my binomial that I need to identify with this one. Note that you have to write it in this form. Don't keep it like this, equals 0. Okay, so this is an equation. Now I can see, okay, so the x cubed coefficient should match with this one. I have a is 1, because this one here, there is 1 here, and for the x squared, there is no x squared, therefore b minus 2a is 0. For the x, I have minus 1 here, that means c minus 2b is minus 1, and lastly, minus 2c is minus 6. I always get 1 extra to check. So this gives me that a is 1 and b is 2. And b is 2, that means I have 4 minus 1, which is 3. That means c is 3. And I can check this one. c is 3. This is just a check. So therefore, my binomial here is that x minus 2 times this binomial here. So it's going to be x squared plus 2x plus 3 equals 0. Because I'm solving it this way, I need to find the values of x, solution of, or the sum of these nested radicals. So I can get that x is 2, or x is a solution for this one. But there is no x, there is no real solution for this one here. Okay, remember that x squared plus 2x plus 3 is always bigger than 0. Okay, you can use the discriminant, or you can just note that this can be written as x squared plus 2x plus 1 plus 2. So this is x plus 1 squared. Okay, it's greater or equal than 0. And if we add 2, we're gonna have 2 strictly bigger than 0, and therefore it's never gonna hit the x-axis, and therefore we have a root or a solution. So therefore the only solution in our case here is that x is 2. So the sum of these nested radicals is x is 2. Okay. I think that's all we have. We did explain this identification issue. We found the coefficients and we checked this one here. And I think that's it. If you see any errors or mistakes, please let us know. Thank you very much.